what's really neat about this is these three photos is I've worked on all three of these projects. This one project was in Drumheller, or solar project. This wind project here in Niagara, and the Haldeman Bess was one of the most recent. That's Canada's largest battery energy storage project. And as I'm building these things, I'm looking around and I'm like, what are we going to do? We need the technology, we need the infrastructure. There's a lot of drivers here too. So electric vehicles, automation, just lights and energy in general, data centers, and all our cell phones and laptops that we have. So now the challenge with solar is it is a really complex material. It is and it isn't. So most solar panels are generally the same, 3.5 feet by 6 feet, and aluminum frames, glass, silicon, some copper junction boxes and leads, and then some backing sheet, or you get into bifacial panels. But the challenge is it's all baked together. Like it's put together, it's put in an oven, and it's all cooked together in like one mass. So it makes the dissection or the deconstruction really challenging. I know we're not really, there's probably not a lot of wind people in the group, but I want to touch on wind as well. So there is a challenge with wind. We've deconstructed two full wind turbines, one in Ontario, one in Alberta. The challenge here, like everything else, everything is recyclable. You're dealing with big bulk, heavy metal components. The blades can really be a challenge, though. All fiberglass, and really not a ton of value, and not a ton of solutions of what to do with that blade material. So as of right now, there are no recycling solutions in Canada aside from Sunset and what we're doing. The current options: landfill, abandonment, maybe stick them in a warehouse, maybe ship panels to Africa. Like, I don't think Africa wants our junk. I could be wrong. Now we have in Canada, this all these numbers are hot off the press from the Canadian Renewable Energy Association. They put out some really good data. I've been a long-term member of CanREA. If you're not a member, I highly recommend. Even if it's not for your own sake, it's just for supporting the association to do the policy and driving the industry. So right now we have 15 million solar panels installed in Canada, 8,000 wind turbines, new installations, like we're on an upward hockey stick trajectory. And the actual volume, I've ran the math of the volume of waste from solar panels and wind turbines, and it does not physically fit in Canada's landfill capacity. So, facilitating a circular economy for this unique waste material is not an if, it's a when. Like we really were behind. I know I've heard from a lot of stakeholders that it's too early for renewables recycling, but I think we're actually behind. We need to really step it up and ramp up the process here. So market size, we're looking at 50 million solar panels by 2050 and 14,000 wind turbines by 2050 in Canada. And then internationally, 12 billion solar panels and 1.6 million solar wind turbines. So that's substantial. Now, common PV panel failure. If you're in solar, you've probably seen all of these. So we have broken glass, microfractures, backing sheet delamination, water infiltration, which creates corrosion of the bus bars, bent frames from wind or even frost jacking. If your foundation's jack, it can bend the racking, that bends the panels. And then hotspot cell failure. And then there's all kinds of reasons for this to happen for any of these failure mechanisms is like catastrophic weather events, transportation damage, construction damage. I've seen it. I've seen trailers come off trucks loaded with solar panels. I've seen guys driving around in skid steers and bumpy farm fields, and they go everywhere. So there's manufacturer defects, junction box and connector failures, diode failures, and then wildlife. We've actually seen like families of raccoons living underneath rooftop solar arrays. Even bird crap can degrade the rubber on the wire, on the cables, on the leads. Now, even if your panels don't experience early loss or end of life, There's repowering. So repowering is a huge trend right now. It's happening. We have about 1 million solar panels in our queue in Ontario, just from purely from repowering. Early panels were about 235 watts. They were monofacial panels, so bifacial has didn't come in until fairly recently. They're P-type silicon primarily, and 15% efficiencies. Now we're looking at 650 watt plus bifacial panels. We got TopCon, HJT, and perovskite, some new technologies that increase the efficiency. So we're seeing about 23% efficiency now and a significant cost reduction. So as technology has advanced, the price has plummeted, and that makes it economical to replace your legacy panels and use the existing infrastructure. So your racking, your foundations, that's all permanent infrastructure. That's all engineered and designed to last 50 years. So, take the old panels off, put the new panels on, you triple your energy and triple your profit, which makes sense. And that's a great, like, we need all the energy we can get in Canada. The challenge is what do you do with those old legacy panels? So not too many people want, a 200-watt panel that's been in the field for 10 years, no warranty. And then even when you do replace them, or like say you take them and install them somewhere else, you need to install triple the racking, triple the foundations. So that is a challenge in itself. Oh, hello, hello. Can you hear me now?
Yep, you're all good.
Sorry, something happened there. I don't
A
know.
little glitch.
Yeah, that's okay. Yeah, we're back. It, in some senses, it does make sense, and we are going to start investigating the reuse, but that's going to take a lot of testing, a lot of analysis, so that we could safely redeploy panels. So right now, the focus of Sunset is on deconstruction. However, I do believe that there are some viable reuse applications, whether it be agrivoltaics or municipal infrastructure. I wouldn't necessarily want to put secondary panels on the roof where my kids sleep, but to put them out in the field to power a water pivot irrigation system in southern Alberta, I think that could be something very viable. So yeah, it's going to take a little bit of time to really refine that, and it should be a CSA approved testing process. So for now, like I say, our focus is on deconstruction. However, if you have a project that's just straight repowering and the panels are good, there's really nothing wrong with them, then happy to have the conversation of like how can we make the most impact in terms of sustainability to redeploy. There's the reduce, reuse, recycle pyramid. We don't want to reduce. We want to deploy, deploy, deploy. But we definitely reuse is above recovery and recycling. So yeah, it's going to take a bit of time to get there. Uh, slide. Come on. What's going on here? Bear with me. It is not allowing me to go to my next slide. Fun. Okay, let's try this again. I just pump through. Boom. Okay, so in comes Sunset with solutions. So we've been working hard to develop technology that can deconstruct solar panels. We've tried it. We've tried a lot of things. We've been working at this for 5 years. We tried crushing, shredding, eddy current separation. Quasi worked, but it was just a mess. There's thermal. We tried thermal scraping, like hot knife systems. Again, very energy intensive and slow. So what we've discovered is that dissection has been our best method, with advanced automation. So what we've developed is a mobile solar recycling unit in a 20-foot shipping container that eventually can actually go to the job site. So when you have large utility scale projects, we can actually go to the site, deconstruct the frames, junction boxes at minimum. We can also do the glass, the silicon, and the plastic separation automated. This could actually be a silver bullet. So I've traveled the world. I've gone to all the conferences in Munich. I've gone to Amsterdam. I'm heading to a conference called SNEC this year in Shanghai. I'm looking at existing technologies out there, and everything I'm seeing is a large static hub facility. Multi-million-dollar facility takes years to commission, and dozens of people to operate and manage. What we're trying to develop at Sunset is or what we have developed is a mobile solar recycling unit that's low cost, low OpEx, low CapEx. So similar to the cost of an excavator or a piece of yellow iron, uh, with high output and high material throughput quality. And yeah, it's actually working out very well. So right now we are doing a hub and spoke model where we have a hub facility in Hamilton, Ontario, and a hub facility in Brooks, Alberta. So you can send panels there. We can receive them truckloads. We've received tens of thousands already. But in certain situations, it may make sense to send these out to the field. And then, down the road, there's an opportunity for international export. So it's a big world out there. That one market slide I had of the global capacity right now. There's not always going to be a hub facility nearby, and transportation logistics are the killer here. You're shipping airspace, the frames sit an inch and a half thick. The glass is only an eighth of an inch thick. So, the transportation is the worst, and that's the biggest culprit of where it's easier and cheaper to send to landfill. So if we can bring the factory to the field, then that's the silver bullet. And there's an opportunity where we can work with asset owners and send 10 containers to Mexico. We can then send them once we're finished that project, we can go to India. So our goal too at Sunset is to service Canada domestically in terms of deconstructing solar panels, but internationally it would be to teach and train the operations and maintenance contractors to run our equipment. So in the international sense, we would just be a technology provider where we can send the units out, offer the training, the technical services, the upstream support, and really enable people to hire local workforces to take recycling into their own hands at a low cost. So here's kind of my videos, some of the work we've been doing with Conestoga College, one of our academic partners. Really neat stuff. They've really been an ace for us in terms of helping with advanced automation. Now, in terms of recovered materials, we're there's a lot of critical minerals here, right? So Canada and the world is on this big critical mineral kick, where supply chains have been disrupted. So copper, aluminum, silver, even silicon metals, those are all critical minerals. Silver is not on Canada's critical mineral list. It is in the US, but it should be here, and I can foresee that happening soon. We're also recovering glass and plastics.
Hey, Dan, just to
Yep.
jump in here, we got a question from Christian. He says, so if the panels are shipped to you, what type of cost recovery is there for the client and a breakdown? And what's the breakdown on that?
Exactly. Okay. Thanks, Christian. So every project is going to be a little bit different for geographic location, panel type, panel quality. Are they still in relatively good shape, or are they twisted and bent? There's all kinds of failure mechanisms, right? Um, so right now we're anywhere between $10 and $20 a panel. And that was a number that we came out with. Like we ran a lot of in-depth math, and we looked at the recoverable value of all the materials, the R&D that needs to be done, the infrastructure development, the labor, the fuel, the time is a big one. So yeah, right now we're anywhere between 10 and 15 or $10 and $20 a panel, depending on panel type. And if it's a utility scale project, those would be the rates. Obviously, if it's every project might be different. If it's a small young family that has some solar panels on the roof that have gone bad, we might not even charge at all, right? It's just we have to kind of gauge the audience of their ability to finance that, right? So yeah, so hopefully that answers your question. And then I was gonna leave it to the end, but they're on our website at sunsetrenewables.com. There's actually a material intake request form, so you can send it in. I'll put out a proposal to you. obviously have a call and see where we can refine it. So whether you guys handle transportation logistics, we can handle transportation. If you guys do the packaging on site, we can also support with that as well. So, yeah. Again, so I put wind turbine recycling in here. I know this isn't the audience for us, but there's some really neat photos in here. So we actually have lots of custom equipment, excavators, loaders, skid steers, big heavy iron that can move this equipment, this material around. We have blades that mount on the end of excavators for cutting up wind turbine blades. And then we've actually like granulated some wind turbine material. And I don't know if that helps zooming in, but like what it comes out as for the fiberglass. So if the recovered material from wind or rare earth elements in the motors and magnets, fiberglass, steel, sorry, fiberglass, steel, copper, and aluminum. So yeah, again, like so we've ran all the math and economics on wind turbines. If anybody here has wind turbines to deconstruct, I'd be happy to help to kind of refine those costs for you as well. This doesn't include the deconstruction of the bases. So if it's a big, large concrete gravity spread footing, we can help with that as well with drilling and blasting and recycling that aggregate. So other services that Sunset
Dan,
offers. Yeah, yeah.
Dan, just jump in again. Christian had a follow-up question. So it is a cost to the end client to recycle the materials?
Absolutely. Absolutely. Yeah. If you look in the United States right now, it's anywhere between 30 to $40 USD. Even in Europe, they have an EPR program there, so extended producer responsibility policy, where you actually pay up front. And I'll touch on that in a bit here too, in terms of policy. So there's a couple initiatives in Canada happening right now. The furthest along is going to be Alberta. So the Alberta Recycling Management Authority, they're going through stakeholder engagement right now, but by the end of the year, I think we'll see extended producer responsibility or some type of stewardship program in Alberta. So I'll leave that to Arma. If you guys are really curious about Alberta, follow up with Arma and kind of see where it's going to be. But yeah, we can expect EPR coming to Alberta by the end of the year. And then Ontario will follow suit very shortly after with RIPRA, the Resources Recovery and Productivity Authority. So, long story short, yes, it is a cost, just like any business, right? Like we have to keep our heads above water in terms of business economics. So yes, there is an intake fee, and that is a nominal intake fee. Like that really does just cover the costs of like triaging the panels, receiving the panels, barcode scanning, the administration of it, the logistics, and setting up the projects. So, we're trying to keep it as low as we can. And obviously, down the road, as technology advances, if there's an opportunity where we can reduce that cost, fantastic. But yes, it is a cost for sure. We've seen it in other jurisdictions. Um, so,
Thanks, Dan.
yeah,
A couple more questions popped in here, so getting a
yep,
little bit more engagement from the crowd.
yeah,
That's
great,
awesome.
awesome.
Feel free to
Yep.
ask questions, everyone. Question came in first from Christy, who says, "My understanding is that the new turbine blades being deployed in the EU use composites that are designed to be dissolved, filtered, and then can be reformed. Is this something that you've encountered or anticipate seeing? And if yes, in which markets?"
We haven't seen it in Canada. When I dissect wind turbine blades, we actually ours are actually a lot more challenging. So you see some photos of like turbine blades being used as bus shelters and playgrounds and that, but in Canada, it's like fiberglass insulation, like styrofoam insulation, fiberglass, more styrofoam insulation, more fiberglass, and balsa wood in there as well. Definitely not recyclable. Well, anything can be recyclable, but not easily. So, we're working with our academic partners right now. We have all the samples. We're doing the advanced material characterization and developing new products of value down the road. So I'm hoping that, like, although it is this mixture of material, maybe we could find some solution for it, whether it's reinforcing fiber in concrete, maybe it's blown insulation. There's a lot of things we're kicking around right now, but we've got some very smart people working on it. I've done our whole team is PhDs, PNGs. Everyone's got letters behind their name except for myself. So what I've done is I put together this dream team of industry experts, and nobody is an expert in two subjects. We all have our own skill sets, so it's been really good. If anybody has anything to contribute to that too, like we're all ears. This is all hands on deck. This is not a hey, Dan and Sunset have the best ideas. It's let's work collaboratively as an industry to get where we need to be. So hopefully that answers your question, Christy. Yeah, I've seen the same thing too. International turbine blades being recoverable, and maybe they are, but even then, you do need some infrastructure to do that. Whether it's hydrometallurgy or leaching, how to separate the fibers out. There needs to be hub facilities and chemical thermal extraction technologies available. Wind turbines are the same idea. It's very challenging, big, bulky material. You got to transport it from A to B. So that's going to be the real kicker is like the cost economics of putting it to a landfill that's close by, half an hour down the road, or shipping it to another country where that hub facility exists. Yeah.
Thanks, Dan. Just a few more questions here that have popped up. Will that be for any system or a minimum size? I think this is in reference to the consultancy fee, like the application fee, or just in general
Um,
costs.
yeah, just in general, we do it per panel. So if it's a pallet of panels, a solar panel is a solar panel. It's just the situations are going to be different, right? If it's a low income family, obviously that's something we don't want to gouge. That's something where I think there's big enough asset owners out there that have millions of panels that where they can kind of not pay a premium on it, but pay the right price, and then that allows those low income families, things like that, where they're not going to be charged for it. But yes, if it's a residential system, we would charge the same as a utility scale system. I know that it's the Costco discount utility economics of scale, but we've worked it down per panel for our deconstruction costing and the cost to receive one pallet of panels.
Very good. Thank you. Next question is, we send our used panels to the local scrapyard. What incentive is there to be sending used modules to you instead of the local scrapyard?
Yeah, local scrapyard is not going to process everything. They might take out some aluminum, maybe the copper junction box, and the rest ends up in landfill. And trust me, I've talked to all the big scrap companies. I live in Hamilton. Hamilton, if you ever gone down by the steel mills, there's five or six very large scrap facilities. I've gone and spoken with all of them. None of them were interested in it. So if your local scrap company is taking them, that's good. But I'd maybe dive a bit down that rabbit hole and do some investigation on what they're actually doing with the remainder of the material.
Great. Thank you. Another question from Christy. How do your fees compare to tipping fees that a landfill would typically charge?
Yeah, so landfill is going to do it by ton. And you know what? That question, sorry, Christy, but that question is just why would you send it to landfill? Like we are a renewable energy industry. We're supposed to be green and clean. That shouldn't even be on the table. Is that type of a question, right? So, landfill is our biggest competitor right now with Sunset. We're competing with their price, and you know it. I, it's your project, they're your panels. If you want to send them to landfill, that's completely fine. No judgment here. It's all good. What we're doing is we're offering a sustainable solution so that the industry can thrive long term. If everybody sends their panels to landfill, that will be on CBC very soon, and the entire industry will be shut down, and we'll all be looking for new jobs. Can guarantee it. You heard it here first. That's my prediction.
Okay, more filling in here. What sort of environmental considerations do host sites need to deal with if you're recycling in a shipping container in the field? Metal
Yeah.
recycling is typically not a land use that is unregulated, I would imagine.
Absolutely. So we're not necessarily smelting or, like melting metals down. It's all mechanical deconstruction. No chemical thermal separation needed. Everything is mechanical. We actually had a consulting engineering firm, RWDI. They came into our facility. We did air quality monitoring and testing, and it came in 0.02% of acceptable working limits. Like we were super clean. And that's for the full, material dissection. So there's different scenarios that we can offer is just to do the aluminum frames and the junction boxes on site. I think that's going to be the most economical on-site deconstruction, just the preliminary deconstruction. So that way you're not shipping that airspace, right? Everything stacks a lot cleaner. So on a typical wooden pallet, you can fit 25 solar panels in a stack, 25 to 30. So now by taking the frames and junction boxes off, everything stacks a lot cleaner. We could put 150 panels on a pallet. So now we've reduced the cost and carbon associated with transportation by over 500%. So it's basically your that material now, that aluminum, so aluminum and the copper junction boxes and the cables, that can now go right to the local scrapyard. That's easy for them to handle and receive. And then the remainder of the material, that can go to a hub facility where we do further deconstruction. So that's what I would offer. But then obviously geographic locations, maybe it is more economical to do the entire deconstruction directly on site. The glass deconstruction, the glass is 80% volume and weight. So if we can take that off on site and we have a local offtake, fantastic. Like we're reducing the cost and carbon on transportation. And then the lightweight material, the plastics, the silicon material, that can go to a hub facility where there's further deconstruction technologies required, like that's where the leaching, the electrochemical separation comes into place, the electrostatic separation. So all we're trying to do is just containerize it and give you different solutions where it could just be the frames, junction boxes, could be the whole gamut. And in terms of permitting, we can work with local regulatory authorities to show them the air quality index, the fact that we're not using any hazardous chemicals. So yeah, I don't see why not, why you can't do that. Now in Europe, policy prohibits that preliminary dissection, and in Europe is also challenging because you can't ship waste material across borders. So that's like you could have a hub facility in Germany and a project in Brussels, but you can't ship the material across that border, even though it's super close. So policy can be prohibitive, but what we're doing is to really refine it to have the data behind our deconstruction where we can defend that and say, look, maybe mobile situations do work. If you're in a remote First Nations community where, shipping everything out is not an option, let's deconstruct into smaller components and then, have containers of aluminum and copper that can go to the Port of Montreal or wherever to a metal recycler. Then the plastics can be flown out or taken down the winter road. So yeah, all different situations and happy to work with anybody on any of their projects to brainstorm ideas and come up with the best solution for you. Yeah, here I'll chug through a bit more of this and then we can keep going through questions. This is great. Hopefully I'm answering them comprehensively for everybody. So with Sunset, we do offer full site reclamation. So we have all the equipment. We have excavators, loaders, skid steers that can remove roads and foundations and fencing and substations. The secondary panel testing, again, we're going to be working through that this summer in Brooks with a group to actually refine them, take the imagery, do the infrared, do the IV curve testing and really triage panels and see if there is an opportunity. I know it's going to be a small fraction and super limited market, so we're not expecting to be, taking your panels and redeploying on utility scale sites. I think again, agrivoltaics, maybe some, small low income buildings, maybe municipal infrastructure. Then one of the really neat things we do at Sunset is consulting. So we've been writing third-party reclamation reports in Alberta as part of Rule 007 for solar, wind, and battery energy storage systems. So what this does, it evaluates the processes required to deconstruct the entire site to reclaim the whole site back to original state. It goes through the costs, so the equipment, the people power needed, the timing of it, and obviously that's scalable for whatever your needs are. For if we need to deconstruct this site in 6 months as opposed to a year, we can scale that. And then it also covers a salvage value of material. So all the steel, the aluminum, the copper, all the material of the site, we take all that into account based on existing commodity prices. So we've done about 40 projects. They've all been approved by the AUC. We've done some expert witness work where it goes to hearing, and then all that is being used for policy advocacy as well. Speaking with ARMA and the RIPRAs of the world, trying to show them data that we can't just arbitrarily pick numbers out of thin air for EPR. It has to be based on factual science and data and existing technologies. So again, so Sunset Facilities, we have two facilities in Hamilton, Ontario. So we have an R&D facility, and then we're working with a glass recycler where we're going to be establishing our first hub, like large scale hub facility in Canada. So pretty exciting, where we can actually deconstruct the panels on site and then send the glass directly to the off-taker. Now that glass is really exciting. So what they do, they grind it down, finer than 80 microns, finer than flour, and they use it as cementitious replacement material. So cement is the highest cost in carbon in concrete. And that, for us right now, that is the highest sustainability impact that we can find for the glass. You can also use it as aggregate in concrete and asphalt as well. Maybe some sandblasting material. But yeah, cementitious replacement material is our focus at the moment. Then in Alberta, we have 380 acres in Brooks, Alberta, just off the Trans-Canada Highway. We're looking to establish that as Canada's first circular center, renewable energy circular center. I think that's important where, academic institutions and industry can all come together and do the applied research and, continuous improvement. It's never that we're going to have, here's our milestone and we won. It's going to be continuously moving goalposts, right? How can we make it better? How can we optimize, automate, and find higher impact reuse applications? And then we have another office and storage yard in Tabor, Alberta as well. So in terms of academic support, so these are our academic partners. So University of Ottawa, Conestoga College, Beyond 21 Academy, McMaster University, SAIT, the Southern Alberta Institute of Technology. They've been a fantastic partner. We're going to be working with them for quite a few years. Mohawk College, University of Alberta, and the Rotman School of Business at University of Toronto. Accelerators. So I've just finished 3 Foresight Canada programs. Fantastic, fantastic group there. Really good mentorship. So yeah, looking forward to continuing to work with Foresight. We've been working with Innovation Factory in Hamilton, the Center for Social Innovation, Climate Ventures, and Mars Discovery District in Toronto. So lots of accelerators are helping us on the business side of things and how to move that forward. And then government, it took a long time, it took years of waving my hands in the air, but we now have some really great support through NRC IRAP, their new clean tech division. It used to be Sustainable Development Technologies Canada, our ITA. I don't know if he's here on this call, but he's awesome, like big supporter of ours and sees the vision and sees the challenge and understands that we need to get ahead of it. The other great group is Global Affairs Canada through ISED. So there's a group called EcoGAC. So we haven't put out the press release on this yet. So this is kind of hot off the press, but we've won their solar recycling challenge. So we're already on milestone 6 with them now. So we've been working through this program since January. But we've defined a clear set of milestones to that we need to hit throughout the year. By the end of the year, our technology is fully commercialized. We're scaled and processing like bulk quantity. So again, the guys at EcoGAC, I don't know if they're on here, but thank you. Again, great supporters, and I look forward to all our monthly meetings. It's been fantastic. And then also for intellectual property, we've been working with IPON and NRCR up as well. So yeah, like we're looking to establish patents where now we can ship this Canadian technology and export it around the world and not worry about it being reproduced or replicated. I do think it's a big enough space where people can replicate. That's the beauty of it is this is an all hands on deck. We're not doing this for money. This is a sustainability issue. That's why I started Sunset. And if the economics follow after, fantastic. But right now, our focus is coming up with solutions for sustainability. Um, Again, so here's some of the media that we're doing. You guys, I don't know if anybody follows us on LinkedIn. We have a LinkedIn page, X, Facebook, all the social media platforms. We've been members of the Canadian Renewable Energy Association since it was CanSIA and CanWIA. Then they merged, and yeah, I've seen the whole evolution of it. We're also members of the Ontario Clean Technology Industry Association. So they've been great too in terms of giving us some support and the resources that we need. The regulators, again, right now, Alberta Recycling Management Authority and RIPRA, the Resource Productivity and Recovery Authority, used to be Waste Diversion Ontario and then turned into RIPRA. There's more across Canada, but I just say these two because these are our beachheads. These two groups, Alberta and Ontario, are the largest market shares. Obviously, East Coast is booming right now. There's different jurisdictions, and it kind of bounces around. But yeah, these two are the big ones that are going to drive the policy. Um, Influencers, we've had multiple discussions with PV Cycle. I went to Germany to visit them. I went to Amsterdam to visit them, learning about what the policy is in Europe. Obviously, Germany and Europe is way ahead of us in terms of solar deployment, and starting to get there on the solar recycling. So again, and then influencers as well are insurance. They're a huge stakeholder in this. And then conferences, I've been going to all the conferences, RE Plus, Inner Solar in Munich. This year we're going to SNEC in Shanghai, and then Electricity Transformation Canada. So if anybody was at ETC last year, we actually had our mobile recycling unit on the show floor deconstructing panels. So I'm pretty sure that's like a world first. I don't think anyone's ever done that. So it's really neat. We were clanging and banging, making lots of noise, and it was awesome. Really, really good show. We had lots of interest on it. So the reason we were doing this is for sustainability as the triple bottom line impact. So one of our sustainability advisors, I took a course, multiple courses at McMaster University, these micro-credential courses where I learned about the sustainable development goals. And that changed the entire reason why I do business. I've been an entrepreneur for over 22 years, and it was always get up, make money, hire people, do what I got to do. Then I learned about the SDGs, and there's 17 of them, and you want to impact as many of them as possible in as meaningful way as possible as well. So the work we're doing at Sunset, we can positively impact 11 of the 17 SDGs established by the United Nations, and that is very difficult for any project to do. So I can't think of a more sustainable project than recycling renewable energy waste material. It just checks so many boxes, and it covers a lot of ground, a lot of industries, whether it's urban mining, waste management, advanced automation, small manufacturing, to renewable energy. And then Canada, we're fortunate. We live in a country where we have all these strategies. So we exceed most of their strategies. So even if you look at this first one, the Canadian Critical Mineral Strategy, it literally has solar panels and wind turbines on the cover of it. Like that's as ironic as it gets, right? So what we're trying to say to government is instead of opening new mines, obviously mine, get where you got to be. but circular economy is key. We've already have a lot of minerals mined, and we need to harness that instead of filling up landfills. So just quickly, so stakeholders, anybody on this call likely knows who the stakeholders are, but there's asset owners, developers, manufacturers, suppliers, installers, engineering procurement contractors, operations and maintenance contractors, insurance companies, government, associations, academia, then of course First Nations and Indigenous communities and stakeholders. So First Nations and Indigenous, they're a huge driver of renewables across Canada. And then using the seven generation principle, we need to leave this place as good as we found it for seven generations down the road. So we got to be thinking ahead and getting future ready. So forward looking, without the technology, processes, infrastructure, and policy to facilitate a circular economy for renewable energy waste material, there will not be a renewables industry in 5 years. So that's my prediction. So what can we do? It's not just all doom and gloom. It's actually great. Like I love renewable energy. I want to see it thrive. That's the whole reason we started Sunset. So what can we do is industry-led stewardship. We can monitor and watchdog ourselves. We don't need government policy. Government policy, yes, it's good, but we can do it ourselves. If we do business for the right reasons and keep the SDGs in mind, we can stop landfilling and abandoning projects. Legit, I've seen projects abandoned. I've seen solar panels on the side of rail trails. Thousands of panels got dumped outside of London, Ontario. Like we can do a lot better than that. And then we can implement reclamation and recycling plans during development or even before development, right? So before we build these projects, we need to really have that plan clear and dialed in. So thank you, Charge Solar, for the opportunity. This is fantastic. Thank you, everybody, for listening to my rambling. But your interest is necessary, and I'm just happy everybody's here today. I'm open. We have lots of questions. Bilal pulling the hook on me, but yeah, so lots of questions. So let's talk. Bilal, if you want to fire away at any of those.
Sure, yeah. A few more popped in here. I don't know that we'll be able to get to all of them, so I might have to cut one or two out. One is from Ian, which says, what sort of volume would you consider to be the minimum required to set up a site remotely for whatever period of time?
Yeah. So we've kind of ran that math too. Depending on geography, if the project is close by, 1 megawatt, we could send it there and deconstruct that site in under a week. Large scale rooftop commercial, there's a lot of space constraints there, right? Where you have a parking lot, it can be challenging. So I want to say like residential and rooftop commercial, that would be send it to a hub facility. If it's a ground mount site, 1 megawatt and above within, a 2 hour radius of a hub facility, that makes sense. To send it, or sorry, under you send it to the hub facility. Over, I think that's where we come to you.
Okay, thank you on that. The next one here, where do the reclaimed materials go after you have deconstructed the materials on site?
Yeah, exactly. So it's that's the challenge. So it's not just build the technology to deconstruct. You have to be thinking about the downstream markets as well. So a lot of people have told me throughout the journey of like just focus on one thing, and you can't. It's an ecosystem, right? So we've been developing, or maybe I can show you a bit closer here. These are some of the materials that we've deconstructed. So this guy's pretty heavy, but this is actually the screws holding the frames together.
Sorry, Dan, you got a lot quieter there.
Yeah, sorry. Can you hear me now?
Yep.
Okay, so these are the screws holding the frames together. So these are just like metal, like those can go right to a metal recycler. The glass, again, so the glass is cementitious replacement material, and it comes out really good quality. Like this is the quality of the glass we're getting, and that's not picked through. This is just a source sample of what we're extracting. Um, the plastics. So this is polyvinyl chloride backing sheet. So we're working to, again, with SATE to characterize this a little bit better. but we'd like to do injection or compression molding with it. We've looked at it like maybe we could do 3D printing filament. There's all kinds of things that we can do. My vision is to actually use this to make pallets because when you deconstruct a solar farm, you have to order thousands of wooden pallets and they just fall apart. It's a disaster. You ship them to us and then we have to do something with the wooden pallets. If we can make plastic pallets and provide those to you at site, that's just it's a good news story of shipping panels on recycled panel material. The silicon. So this is like a silicon, silver, copper mixture. So we're working with SATE to characterize it again, and we're also working with the University of Ottawa to electrostatic separation and a little bit of like leaching thermal separation to see what might be the best. It may be a combination. So this material here, we're still working through it, but the silicon, I'm picturing using it in the steel manufacturing industry as a rust inhibitor. So again, being from Hamilton, there's lots of steel mills here. We can get this to the steel mills. That would be a big win. And then obviously the silver we need to extract because that's the economics. That's really where we can actually like build a business out of it. And then the copper bus bars in there as well to extract that. Now, in terms of the bus bars, we've actually smelted down copper. So this is one solar panel worth of copper right there. So I don't know if anybody can see it, but that's like pretty neat. It's yeah. So getting that copper back into the circular economy, that's a no-brainer, and the world is super copper hungry right now. This is the silver material like broken down. So what we've done is mechanical separation.
We lost you again, Dan, if you can get a little bit closer. Sorry.
Yeah, sorry. So this is the silver material here. Can you hear me now?
Yep.
Yeah, okay. So this obviously we did this through mechanical separation and now again working with the University of Ottawa to extract the silver and get that into markets. The aluminum, again, no brainer. We bring that into any scrapyard. Again, we've been working with a few partners across Hamilton, and same thing with the junction boxes and the copper leads. So 100% of a solar panel. Like right now, we've got it 95% by weight and volume, but that other 5% is the silicon, and we know that we like that is a must. They're doing it in Germany already. We've been talking with some folks over there. So that's by end of summer, I fully expect that that'll be downstream markets, off takers approved. So right now we're 95%. That's the bet. There's nothing in Canada. Like so by de facto, we're the best and the worst recyclers in the country. So
Thank you. The next one here is from Michael. Where would um, the used modules physically be sent?
yeah. What do you mean? Like so the testing of the modules, like tested modules where they would go from us or
I,
for used
I
modules?
ex Yeah, I expect the question is more along the lines of if the used modules are going to be reused,
Oh yeah,
is
yeah,
what
yeah.
is the facility that it's being sent to and like the plan for them longer term?
Yeah, so right now, again, we have hub facilities in Brooks, Alberta and Hamilton, Ontario, where we can bring these in and triage them. Um, if it's an insurance project, they can't be reused. If a customer says, hey, these cannot be reused, no problem. We're just straight deconstruction. But if a customer says, hey, our panels might still be good, would you be able to do some investigation on them, test them, see if they can be redeployed? Fantastic. And lower wattage panels, the reason why I say agrivoltaics is because the power production on agrivoltaics is a byproduct. That's secondary. The farmers are looking to shade their crops. I have a neighbor up the road. He wants to do a 30 megawatt agrivoltaic project on an apple orchard because last year he lost 30% of his crop from sun scorching. So it's more so just to have the shading and then the wattage is extra. So in that case, using lower wattage panels, that might be a really good way to go because then you can cover more ground without exceeding grid capacity for net export, right? or net metering. So yeah, that's why I say agrivoltaics. The other side of it is municipal infrastructure. Working with municipal landfill transfer stations. So part of our work at Sunset too is not just to have our own hub facilities, it's to enable municipalities or municipal transfer stations to receive panels. And then when they accumulate to a certain threshold of 1,000 panels, then they can either transport them to us or we can send our mobile unit to the transfer station and process directly there. So that's where I'm thinking, offsetting some of the municipal infrastructure just to create clear span metal structures, similar to a large carport system, where we can then do the work and you can actually stockpile those panels underneath. It'll reduce the operating expenditures of the landfill and it'll reduce their carbon off gassing as well. So it's like it's a win-win-win. But again, it's all situational. So if a customer says deconstruct, we deconstruct. And we prove it out as well. So every single panel that we process is time stamped, and the every single panel has a unique identifier, the barcode on it. So we scan that barcode as it's being deconstructed. So you get a Excel spreadsheet afterwards showing every single panel that we've deconstructed, when, where, and then we give you a certificate afterwards saying that it's completed. And even as we receive them, we give you a chain of custody letter saying that you're no longer responsible for these panels in any liability, way, shape, or form.
So thank you, Dan. That leads into another question here from Edwin, which says, for some of us planning smaller 90 panel projects on buildings, what recommendation would you have for us? Does that apply to that question as well?
Sorry, 90 panel
Like
projects?
a system 90,
Yeah.
100 panels on a system, what would be the best approach there?
Absolutely. So if they're coming down, it's going to take us some time to actually get working with all the transfer stations to create that distributed collection network. But for 90 panels, that's what, 4 pallets. So that's like call a Manitoulin transport. A small carrier, maybe not like a full 53-foot flat deck, and transport them to either Brooks or Hamilton. So. We have our own trucks as well. Like there may be some situations where we could do a milk run and like go multiple sites and collect. But yeah, for 90 panels, I'd say that's 4 pallets. That'd be a Manitoulin where they have a lift gate and they can bring them right to us.
Okay, thank you, Dan. Just a couple of more questions here as we're running critically short on time. Somebody asked, can you speak to BESS?
Yeah, I can. So I've ran all the math. I've done my research on different systems.
It wasn't
The
my
te-
question, by the way.
yeah, no. The Tesla Megapacks, the Canadian Solar Soul Bank systems, great technology. And actually, Paul, we were talking about this yesterday, looking at some
Right.
technologies and everything. I've been looking at tech as well. And we've seen some utility battery scale recyclers like Li-Cycle come in and go. We've seen companies up and down. So in terms of Sunset, we're tiptoeing into the battery world. But definitely our focus is solar, wind, the battery recycling that may come in time, but I have some really close connections with large industrial lead acid battery recyclers, and they won't even touch lithium batteries. So there's got to be a reason. These guys are very involved in the battery world. So I'm kind of I gotta listen to them. There's got to be a reason why they're not touching it. So.
Another question. What insights do you have into ARMA's plans? Um,
I wish I could give you the full answer, but Arma, they are doing their next community engagement session is on the 16th, I believe, April 16th. And it's an open public webinar. Anybody can hop in there, ask the questions. So I'd encourage everybody to be on there because it's important that they get it right and that we give them the feedback as industry, because it's only going to make any EPR stewardship program stronger, right? So, um, they've been kicking around for years. They did a solar pilot study where they took in some panels, tested them. A lot of them ended up getting shipped to the States, which kind of I don't know, defeated the purpose of the pilot study, but I digress. It's okay. We're looking ahead. So how can Sunset support ARMA and support the provincial stakeholders? So I think the goal is for Alberta to be a Western hub for British Columbia, Saskatchewan, even Manitoba to go that way, and even northwestern U.S. There's no solar panel recycling in northwest U.S., so that material can actually cross border and come into Alberta as a hub. And then same thing, Ontario is the Eastern Canada hub for solar at least. I recognize that wind is really taken off in the East Coast from Quebec right to Nova Scotia and Newfoundland. Like there's some large project happening in Quebec right now. So maybe like a wind hub. Uh, Maybe there needs to be a wind hub in every single province. Like yeah, there's a long way to go. I'm not saying I have all the answers. It's just, we've put a lot of thought into, what this system could look like. And that's where we need everybody, all hands on deck, everybody coming up with some solutions. So
Awesome. Just a heads up, we are at time, so if anybody needs to jump off, feel free. Dan, if you're open to it, we can run a couple of minutes after the
I'd,
time limit here and answer a couple of more questions, if that's okay with you.
I'd love to. I eat, breathe, sleep, renewables, recycling. So this is really good feedback. It's only making my wheels turn as well. How can we service people better? So
Great. And anybody who needs to jump off, just a reminder, Dan's email is right on the shared screen here, so feel free to reach out to Dan with any other questions that aren't answered today, and I'm sure he will have some answers for you. Next one here is from Steph. When analyzing the ROI of a project being built in the near future, do you have a recommended rough cost per panel or per watt to use on what the asset owner should plan for recycling in the future?
yeah, there's a lot of variables again. I'd say, Steph, if you were to hop on our website, there's the reclamation plan request form, and it's super easy. It's basically like it's a one pager with some of the site data. We can send you out an NDA as well, and that way it's covered. But yeah, it doesn't take a terrible amount of time to really look at it. Even if I were to look at like location, scale of the project, type of foundation is a big thing too, whether it's helical piles or driven piles, road construction, substation size, transmission infrastructure. There's too many variables to give you an accurate number, but happy to look at it case by case.
Okay, I think we'll do one more question here. The hub facility um, site, what's the hub facility site area required? Each 250 kilowatt site is getting repaneled, generates a couple dozen skids of panels that need to be shipped to the hub for pre-processing. What are the logistics there around like the various system sizes
Yeah,
I would say smaller to medium sized commercial projects?
absolutely. So we have a lot of space. So Alberta is 380 acres. We can intake anything. Lots of room to work there. Ontario, we are a little more constrained, but there's still plenty of room again. And then the objective right now, we have two recycling units that we've built. We can scale the technology. We at full manufacturing, we'll be able to build a unit every 2 weeks. So it's basically like quick turnaround time, low OpEx, low CapEx for us. The goal is to have enough units there that we can scale to the incoming materials. So the sooner you can talk to us about your requirements, the more prepared we can be to have those units in place, the employees, the training to go along with it. And that way we can deconstruct as quickly as the material comes in. Like right now, one unit, we can process 500 panels per day, to put it into perspective. So like if we have 10 units, we can process 5,000 panels a day. So it's, let's get talking. We'll get communicating on your projects and see what we can do in terms of logistics. And the more pre-project planning I always say pre-project planning prevents poor performance. So we want to start the dialogue early so that we can get where we need to be to service your project and any other projects that also come in simultaneously, right? Like right now, we're looking at 1 million panels in Ontario just from repowering and manufacturer defects. So pretty substantial.
Okay, great. Thank you, Dan. Thank you, everyone, for your questions. I think we're going to call it there. I will pass it over to Amber for closing remarks.
Yeah, just thank you so much, Dan, for sharing your insights and your passion today. Thanks to everybody on the call for the thoughtful questions. That was very, very insightful. And of course, to Bilal for facilitating the questions. Yeah, that concludes today's session. Enjoy the rest of your day, folks. Thanks again, Dan.
Thank you, Charge Solar. Thanks everybody.
Bye, everyone.
Okay, take care. Bye.